So our first presenter is Victor Lee, who's a professor at the Stanford Graduate School of Education. He leads the Data Interactions in STEM Teaching and Learning Lab, and through his research, he creates new opportunities for people of all ages to learn STEM content and practices with the support of emerging digital technologies. So thank you, Victor, and the show is yours.
Thank you, Dan. And like you said, I'd like to talk about data, and I'm going to talk about data science and education, but I'm going to turn the tables a little bit. Right now, when we hear about data science and we hear the word education, we typically think about some pretty exciting things that can be done, like use student data to personalize and adapt curriculum, to recognize facial expressions, to help us identify and respond to patterns or clusters of online learning behaviors. So that's typically what we think about when we hear data science and education. But the way I want to turn the tables on data science and education is that instead of having data science be the tool that figures out what learners are doing, is to instead have the learners figure out what the data science is doing. And my proposal is that we keep making headway on these cool tools and applications of data science and the algorithms that are developed, but we also invest the time in finding new ways to make data more intuitive to students. So in a sense, what I'm proposing is we transform learning by taking on the work of training the next generation of data scientists. Now, why should we do this? As Dan had said, data are inundating the way we live, work, and play. We are producing right now petabytes of data every day. When we snap a selfie, or we talk to our voice assistants, or shop at the grocery store, data is basically becoming our societal bloodstream. And if I were to stick with this kind of body systems bloodstream metaphor, we would definitely want to train doctors who can help make sure that all the data is working the way that we want. But it's not just going to be a need for data doctors. We're going to be better off when everyone can do their part to help us maintain good data health and data hygiene. Because now data could, and perhaps it even should, play a bigger role in shaping the kinds of decisions that we're making. But that involves making sure that we have a really broad base of understanding about how data are used and knowing how to work with it. And so that means transforming learning. So it involves better tools to help people develop data literacy, because we want people to think well with data, and we want them to think critically, and we want them to think statistically. But that last part, thinking statistically, that's hard. Why is it so difficult for us to think statistically? We easily think associatively, we think metaphorically, we think causally, but statistics requires thinking about many things at once, which is just something that our intuition is not designed to do. That's from Danny Kahneman, Nobel laureate in economics. He's part of this previous generation of cognitive scientists and cognitive science research, lots of it that had come out of Stanford, that established we really struggle with statistical thinking. And that means we really struggle to develop data literacy. So what do we do next? Push more people to take stats class? If it's going to be like my experience, and I do have a math degree, more statistics instruction is not going to be a cure-all. And we could try rebranding stats class as data science class, but that's probably going to just attract the people who are already drawn to that topic. It's not going to bring in the throngs of students and give them the seat at the table necessarily either. What we need to do is we need to think about different ways of teaching about data. Would it help to have more class options in schools? Sure. But we need some fresh approaches to make data feel more intuitive, not less. And so this is where this entire work of this Transforming Learning Accelerator that's bringing in learning sciences and design fields, and where that can all come in. We do the work here of combining the science of cognition with the expertise we have about social interactions and technology and design, and use that to transform learning across contexts. I'm going to talk today about schools, but there's a lot that we do outside of schools. We bring in the entire toolkit, the combination of qualitative, descriptive data, quantitative research, computational and analytic style methods, find out what works, partner with educators in the messiness of the real world instead of the coziness of our laboratories, and spend time kind of looking both inside and outside of current educational systems to find solutions that work. So let's go with that last point. Look inside and outside of the current systems. with the pandemic, it's become pretty apparent to all of us with school-age kids that school serves some pretty important roles in our lives and our communities. There are people working right now in our school systems who have been going double time, nonstop for the past year to provide what students and families in our communities need. And we should absolutely respect and appreciate that. There is a lot of good work that's happening because of the frontline workers in our education system. But at the same time, there's value in being curious, as Nick Haber had illustrated, but there's value in being curious and trying new things. See an interesting idea that exists somewhere else that's not school, and wondering, exploring what might that look like if we gave it an education bent. And this is where I want to focus with my remaining time. I want us to look at what's been called the quantified self movement. Many of you, some of you, have maybe heard of it, but if you haven't, what is it? It's the integration of numbers and data into our everyday activities. It's the idea that data made by us can also be for us. So like if you look at your wrist, you might see a Fitbit or a smartwatch, and that's the quantified self just sitting there on the back of your hand. You look around your home, you might see it in Internet of Things technologies, smart thermostats and smart meters that keep track of your energy usage. If you use Spotify, you'll see it in your yearly music report. This is just one of the ways in which data are becoming part of our everyday lives. And my question is, what if we could use this quantified self movement for learning? So I've largely focused on, in my work, wearable devices and activity tracking tools that are part of this modern age of what we described as techno-athleticism. We use digital technology to keep track of our step counts, get reports on our running speed, and monitor our heart rates. The idea is that by moving around, we're producing our own big data. So what if instead of having this big data approach where the data that we produce goes to some company where they have people crunching the numbers and technologies, making recommendations, and get to a situation where the users make the data and we give the data right back to them. And if we could take advantage of how familiar and personally relevant those data are, could we devise some interesting new ways for people to learn data science? So this is something that I've worked for the past several years with the support of the National Science Foundation and my colleagues to make happen in the classroom with elementary and middle school age kids. What we do is we provide new ways for students to capture and visualize their own data. So we turn their everyday lives into statistical learning laboratories. And using that approach, we help students make new insights about statistical ideas that are basically that core of data science. So here are some examples. Top left, a student looking at a data visualization of step count data made by her entire class when they use their footsteps to measure the length of their playground. In this gesture analysis here, I've talked about in some writings how this particular girl goes on to explain how all the different segments in this statistical distribution work and talk about what it is that the students in her class did that made this bell curve shape appear. That's something that actually a lot of college students struggle with, explaining sort of why the bell curve looks the way that it does. But based on a video analysis of a middle school student, this youth did it. These middle images, we produce big data from our wearables, provide it with students. You get a lot of big data about their movements throughout the day. So here's a Tableau visualization of student movement activity across 5 days of the week, Monday through Friday. And we showed representations like this to students, and they can see this and pick out immediately where's recess, where was PE, where's the part where they sat around for language arts, and they can tell this whole story about the entire data set. And one of the things we really want people to be able to do with data now is use data to tell stories or to find stories inside of data. And when it's their own data, they can. The middle right here is a student design comparison project where this fifth grader compared how her teacher's Fitbit performed compared to her teacher's smartphone step counting app. And she found out that there are some actually pretty big discrepancies between those two technologies. So we might have a future QA tester on our hands. And then the bottom two panels was from a project where a class of students were wondering if that feeling of having to do more work to walk uphill, if that actually involved taking more steps than going downhill, where you have that easy sort of momentum pushing you down feeling. So they went ahead and used Fitbits to obtain data. This is their comparison uphill to downhill. And yeah, there was a small difference. So given the opportunity to work with their own data, I found time and again that students, elementary, middle school, they can come up with some pretty interesting things to investigate, and they get much more comfortable with thinking about and through data along the way. We've run some comparison studies on student statistical reasoning when they follow the current data instruction that's provided in schools. That's shown in the white bars in the graph here to the right. And when they do quantified self-style approach to using data, so that's over here in the gray bars. And the really short version is things look pretty good for a quantified self approach. We interview teachers both before, during, and after they do quantified self-style instruction. And we keep finding they have really positive things to say. Here's a quote on the left from a teacher we'll call Ms. H. She taught a 5th and 6th grade combo class, and she volunteered for us what she noticed that happened with one of her students. She said, well, Olivia, she really struggled with math last year, did not enjoy it, was often confused. And with quantified self, she became one of my most engaged students, often volunteering, often raising her hand with insights and explaining to other students. And she was one of the ones that was super excited about the way data was going for her. And she gained a lot of confidence. So this is the sort of thing that if you saw what Joe Bowler was talking about, that we can make happen with students when we give them this quantified self data. It's encouraging. This idea, give students back their data and use that to learn data concepts. Interesting things can happen. I've talked a lot about elementary and middle school. That's where I spent most of my research and design time, but I've done some stuff with high school age students, set up informal quantified self experiences that are similar to these online based meetups that the quantified self community practices. These students get access to new wearable Internet of Things technologies, and start to design questions and projects. And we look at what it is they ask and figure out when they have this data nearby. One student we worked with looked at how her tracked sleep correlated with her mood the next morning. And it turned out that the amount of sleep she got did not end up looking very predictive about how she felt when she woke up. I've done a small collaboration with a fellow in England who's documented how students can come up with some pretty interesting visualizations of their own data. So this heart with the lines coming out of it shows moods and intensities done by a high school student. So overall, I think we are getting some really good evidence that interesting things can happen if we give kids rich data experiences and if we help them work from their own data whenever possible. And to summarize all of this, this quantified self approach to teaching and learning, it has some potential. It can offer something a bit different, perhaps a little more accessible. And why do we want to help students with data? Well, it's going to be good if data is more accessible, but there's this longer end game that we'll need to keep in mind. Next generation needs to not only be able to read data, but understand how data are useful and used with technology. I think Emma Brunskill will be describing some of that later. But why are we so hyped about data and data science right now? It's because we can do interesting things with data when we use machine learning. And then this can help inform and be part of the artificial intelligence technologies that are getting all the buzz right now. So I have a Google Ngram here on the bottom right. And you can see that the terms data science, artificial intelligence, and machine learning, they're all riding the same wave moving upward since 2010. And what we want to do is, get students to understand how data fit into artificial intelligence, not just make this something that only computer science students who study it in college find out about, but something that all students throughout K-12 can have access to. It's already becoming part of their daily lives, and they need to know about what's happening under the hood there. So if we can channel some of our energies and talents to helping the next generation get a bit more data savvy and be prepared to improve how it is we use data in our world, whether that's personal decision making or the next generation of AI technologies, then I think we're going to stand a pretty good chance of transforming learning with data. Thank you.
Thank you, Victor. Very interesting. I can imagine they get fascinated by their own data. So one thing, I think when I was in middle school, I got exposed to like a bar graph and a line graph. Like, how many different data visualizations do these kids get exposed to when you bring them through these sort of quantified self experiences?
There's a lot of potential there. There's a lot of standard forms that are easy to come by, whether it's histograms, box plots, bar graphs, line plots, time ordered plots. But there's also a lot I think we need to expect and better anticipate, which we're not doing right now, which is where we get these awesome, beautiful new data visualizations. We're not covering that really well. But here's a chance to actually kind of bring that art and science together with the computation. So to answer your question, they encounter a good number. Could they encounter more? Could they invent more? Yeah, I think so.
Cool. Very cool. So thank you. Our final speaker, bringing us home, is Emma Brunskill. Emma is a professor of computer science at the School of Engineering, and she leads the AI for Human Impact group. Her research addresses how we can learn from experience and data to make good decisions. So welcome, Emma.
Thanks. I'm really excited to be here, and thanks, Victor, for the great talk. So I think that my talk follows on nicely from Victor's, which is when Victor was describing sort of these amazing different types of experiences that students can have when they learn, there's all these amazing instructional decisions that have been made in order to create that type of experience. So for example, this is a particular game that I've had a chance to work on before. It was developed from some of my colleagues up at University of Washington. It's a game to teach kids fractions, which turns out to be one of the key skills that a lot of students struggle with. And you may have heard about it already today. So in this game, you can see that there's sort of a number of different design choices that were made. There were choices around how to display fractions. There were choices around whether or not to include gamification. There's even things like whether or not to play music or not. And you might imagine that in the sort of the right way to customize this particular educational environment depends on the kid. And that's not so surprising. We know that that's true for lots of different types of learning experiences. Whether we're looking at something like how to acquire factual knowledge, we know that spacing and repetition depends on the student and how they're doing on the previous activities. And we know that for many different types of things, essentially personalization is the cake. It's what we need to get right in order to help students succeed. But I think that when we think about doing this, and there's a lot of talk about personalization, it's also really useful to recognize that that may need to change how we do science. So if we think about sort of standard experimental design, what we often have is we have sort of two groups. We might have two different types of interventions, and often there'll be much more exciting interventions than the ones I've shown here. But imagine that, in this case, we're just looking at whether you have a book or whether or not you have some sort of worked problem. And what we often do is we sort of divide people into groups, and then we try to understand, on average, which of these two interventions is better. So this is sufficient if what we want to figure out is whether we should give everybody a book or everybody sort of a worked example. But that's not going to work when we want to look at personalization. So what we would really like to do instead is to figure out for each individual at a particular time point what type of learning experience is going to be most effective for them. And so we'd like to have something like the following, where we have this sort of like targeted, personalized experience for each individual. But the challenge for that is that now we don't just have two different things we do, we have many, many more. And let me just illustrate that here. So if you think of, for example, there'd be maybe 10 different types of learners. And of course, there are many, many more types of sort of backgrounds on learners and sort of stages of learning than that. But imagine right now we're just considering 10. And then we could either give each of those 10 different types of learners either a book or a worked example. that's actually the number of learners to the number of sort of ways we can teach them. So that's already 10 to the 2 or 100. And in general, we have way more types of features of learners we might like to condition on in order to make decisions. And we have many more types of learning activities than just 2. And so that means that we're not going to be able to do things like standard experimental design because there's just way too many of these different types of ways that we could sort of match learners with the right activity to give for them at this time point. And so we're going to need to do different types of things from the perspective of how do we do science effectively and efficiently to try to wade through this space. And that's a question that me and my lab have spent a lot of time thinking about, mostly from the perspective of sort of statistical machine learning. So in particular, we sort of think about 2 kind of broad categories of things. We talk about decision policy mining, and I'll define what I mean by that shortly. And then we also are thinking a lot about how do we do different types of experimental design when what we want at the end of this is a personalized decision policy. So let me just talk briefly about the first. So we often, fortunately now, have large amounts of data about past decisions and their outcomes. So just like Victor was saying, we often have traces of, as a student, say, goes through a massive open online class, what activities they did, how they did on quizzes, what videos they watched, and maybe whether they passed the class or failed, or how they did on the final exam. And we might have this for lots of different individuals. And what we would love to be able to do is to leverage that historical data in order to make sort of decisions for a new individual. So can we somehow sort of take that old data and use it to inform what might be most effective for a new individual? Now, in some cases, some of those prior decisions might have been made by experts. So maybe, someone has a coach that is helping them sort of go through the class and figure out like what types of activities might be good depending on how they've been doing so far. So in that case, we might want to do what's called imitation learning, which means essentially we want to learn how to mimic the decision makers, sort of that expert teacher who was helping those previous students through the course. How could we sort of make that into an algorithm and something that a computer could scale up? And that can be very effective if the way those decisions were made in the past were really effective, like if you had a really good teacher that was guiding those previous students through the course. But of course, ultimately, what we're interested in doing is we're interested in finding really effective ways to help support a student as they learn. And it might be that those previous decisions of what to learn when were not necessarily extremely effective. So maybe those were by the students themselves, sort of trying to figure out which videos to watch when and when to do the quiz, and did it make sense to go back and rework on that essay. And so in those cases, what we'd really like to do is to leverage our historical data and figure out what we should have done, what would have been a better way to perhaps teach these previous individuals and future individuals in order to be most effective. But of course, this requires us to think about one of the foundational characteristics of human intelligence, which is our ability to reason about what if. What if we had done something differently? For example, what if this final student I have on the slide had been taught in a different way? What would have happened? Now, in general, that's a really hard thing to do. And so we have to sort of look at a number of different tricks and statistical approaches to try to see when we can help answer that question. And I'll give you a brief example of a place we've looked at this before. So this was a project that we started about 7 years ago with my colleagues up at University of Washington, where we had this fractions game, which was sort of helping students learn about fractions. And what a personalized policy here means is that we can condition on what is the next activity to have them do based on how they're doing so far in the game. So for example, we could condition on whether they took 30 seconds or more to complete the prior game level, but really there are many features we could use. And so what we wanted to use is to use our historical data, which had sort of random activity ordering that was given to the students, and figure out what would be a good sequence that could allow the students to persist longer and learn more. And the key insight that we had here was to leverage a technique from statistics called importance sampling in order to sort of reweigh our historical data to look more like the type of data we might get if we were to use this more effective way of teaching. And what we found in this case is that we could do what we're calling policy mining to figure out a better personalized policy that actually increased student persistence by 30% when we did another study with 2,000 learners. So what that indicated to us is that we really can sometimes take the historical data and then use it to figure out more effective ways to teach students in the future. So since then, our lab has done a lot of work in this space. And one thing that we've been thinking about a lot in the last few years is how to think sort of more precisely about the fact that, sometimes we may have a lot of data, sometimes we may have a little data, and what type of modeling assumptions are we making? For example, it might be that in the historical data, maybe most of the time students got a worked example, or maybe they did particular examples, and maybe only a few students were assigned reading. So in those sorts of situations, we might have different forms of uncertainty in terms of how confident we are that one type of teaching or another is more or less effective in different situations. And so what we would like to do in those cases is to sort of be very explicit and quantified with the type of modeling assumptions we're making and whether those might involve errors or have misspecification, and the fact that we only have limited data. And if we have limited data, then maybe we shouldn't be too confident in terms of things that perhaps we've only tried once or twice. And so this has led us to an approach that we're calling pessimism under uncertainty. And the key idea here is that if we don't know very much about how some interventions might work in some scenarios, for example, maybe we very rarely given a student a reading material in certain situations, then we should be pessimistic about how effective they are. And that may sound sort of surprising, but the idea is that that's a way for us to be formal about the fact that we're not sure what might happen in some scenarios, and to get personalized policies that are more robust to these type of assumptions that might fail. So in particular, we're now using this type of approach to think about doing personalization in a chatbot. So this chatbot is a collaboration with James Landay, who's in the human-computer interaction part of the computer science department, and a number of wonderful students, where we're trying to teach kids about volume using an interactive chatbot. And the question is, how can the chatbot best support the students while they're going through these activities? So we're trying to use historical data that we've collected from earlier experiments and see if we can figure out more robust methods using this pessimism under uncertainty in order to be more effective in helping students in the future. Now, before I finish, I just want to very briefly talk about this sort of new initiative that we've been doing in my lab over the last year, and that's called policy experimental design. So again, remember before I said that in general, we have just sort of so many different ways that we could try to sort of customize and personalize different interventions to different individuals. And it's not going to be possible for us to do standard experimental design for all of this. What we've been thinking about now is sort of a new type of pipeline in machine learning and data science, where we think sort of explicitly about doing kind of optimal experimental design for trying to extract these type of personalized policies. And it'll change the way that we gather data. Instead of having sort of uniform assignment across all the types of different conditions or potential policies, we can try to be strategic with the structure that we have to see if we can lower the amount of data we need and still be able to find policies that are highly effective. And so that's a big new initiative that we're doing in my lab that has implications both for education, but also for other areas like criminal justice and healthcare. So just to summarize, these steps are ones that I think could really allow us to provide the right activity for this time, for this individual. And those sorts of interventions, I think, could really lead to transformational impacts in the efficiency, engagement, and effectiveness of learning. Thank you.
Thank you, Emma. So just to remind everybody, you can ask questions through Google Forms on the TLA website. It's transforming learning, one word, .stanford.edu. And while people enter their questions, I'll ask you a quick one, Emma. So is there any place left for theory? Or is this just, if we had enough data in the world, we could describe everything and we don't need a theory?
Well, I laugh at that. That's a great question. I laugh because in my world, theory means proofs and theorems about math, and so there's tons of proofs and theorems in this math. So of course we need theory. It tells us how much data we need. But I think in general, the theory of learning is still incredibly important because it guides which interventions and which types of activities are likely to be effective at all. So I think like the types of really incredible activities that Victor is looking at, or some of the ones that I've had a chance to work on with James and other people in human-computer interaction, those have an enormous impact. And I think if we just are looking at sort of how to sequence a bunch of activities, none of which are effective, we're not going to end up with transformational learning. We're just going to end up with not very good learning in a particular sequence. So I think that coupling these sorts of statistical machine learning insights with people that have a sense of what activities actually can be effective is really the most productive way for making progress.
So it reduces the search space.
Exactly.
A good theory. I have another answer, but I'm going to wait because we have a question which I normally won't ask this because there's sort of values about what we want our children to be. And that's probably not for the scientists to decide, it's for the public. But this is the hardball question, and it's for Victor and Emma. And I'm going to read the whole thing because it captures a certain sentiment that's out there. How much is personalization depriving students of developing their capacity to adapt to different learning environments? And similarly, as we see narcissistic tendencies on the rise, are we feeding the beast? Should young people expect teachers, professors, employers, and trainers to adapt to their world rather than vice versa? Are we pandering to the kids, damn it?
Fascinating question. So I think where we need to think about this is, are we trying to look inward or outward? If we use inward as the resource, the things I experience, the things I know, the things I encounter, help me to make sense of what I encounter outwards, then I think that's really consistent with decades, maybe even centuries of educational theory about how we learn. What we want to avoid, of course, is a situation where everyone feels that their perspective is superior to other people's. And this is where I think maintaining what we value a lot in schools, that social interaction, that range of diversity that's represented by students all being in the same space, has a lot of value, and we wouldn't want to give that up, because that is where a lot of those negotiations have to take place. That's where we're going to get exposed to and challenged with our ideas. And we can always do more to better engineer that so we have a bit more equity and access.
Very good.
And I think to add on to that, the way that I would view that, and again, coming here from my sort of machine learning, computer science hat, is that I think that the values of having students be adaptable, and being able to integrate into lots of different environments, all those things are incredibly important. And I would put those as sort of some of the important goals of education. And I think if those are the important goals of education, then what these sort of personalization systems can do is they can help students learn those type of skills. And so I think of sort of the personalization as being a way to more efficiently and effectively achieve the goals that we want for education and for our citizens and our children to learn. And they're not necessarily, they don't have to be in service of other types of objectives, like just fitting to say how we think a student might learn most effectively right now. It's really just trying to work smarter instead of harder. We're trying to figure out more effective ways to achieve the long-term values and ideals that we want from education.
Right. And in your environments, do the kids even know it's being personalized to them?
That's a great question. I think it varies. We don't always ask them. I think sometimes people realize things are being personalized and sometimes not, and we also do Wizard of Oz studies where we compare between having humans do the personalization and machine learning systems do the personalization.
And
well, those things sort of vary, of whether or not people can pick up and they can distinguish between those types of cases. And I think there's a lot of open questions for how do we better sort of augment human teachers so that they can even more effectively and efficiently do all the wonderful things they're already doing.
So let me go back to the earlier question about theory. So, and this is for Emma. And when you do these reinforcement learning to learn policies, the discoveries are kind of tied to that specific environment. And do you learn something that you can help you make policies in another environment besides learning how to make good algorithms that find policies?
I think, I think it's a great question. So, Min Chi, who is a previous postdoc in your lab at Stanford, some of the work that she's done recently that I really like is to try to extract generalizable sort of rules or insights from decision policies. Um, in general, these things may or may not transfer in terms of generalizable insights about the science of learning. I I think that in general, the place that I've seen these be most effective is to take more general principles of the science of learning that are not specific enough to prescribe what should we do in particular environments, and then use machine learning and a data-driven approach to sort of do that fine-tuning or customization. I have not yet seen places where they unearth completely different insights about the science of learning, though that's possible that they could, and they can certainly be used to test hypotheses. But in general, they will be sort of reflecting particular findings for this particular case.
Very good. Very good. I was just looking at another question that's going after the personalization question. But I think that makes a lot of sense to me. This is the third hour, so I'm going to continue to be a little punchy. Who do you think's more efficient to choose how to personalize education? Students or teachers or machines? Should the students get to choose? Should the teach? I know there's no answer to this, but it's a fun question.
I will say there's at least some nice work on this in the sense that Candace Till and John Basson and some others have a really nice paper where they compare students choosing versus reinforcement learning machines choosing. This particular case, machines win in terms of the better outcomes. I think actually it's a lot to ask students to choose. I think giving some autonomy, but like actually expecting people to be able to do not just learning the new material, but meta learn the most effective way to learn that new material. It's at least something I still do not know how to do. When I say that as a tenured Stanford professor, it's really hard to figure out the most effective way to learn some new material. So I think students often have insights into what they know and don't know, but I wouldn't expect them to know the best way to teach the material. Teachers, I think, often have an excellent idea, but there is a huge benefit to being able to see an enormous number of students, just like how I got better at teaching over time. And that is what machines offer us. If you have a huge data source, they can see, effectively like hundreds of thousands of students. And so just like in healthcare, that often reveals some interesting insights that are hard to get at, if you've only seen 20 or 40 students.
Yeah. Yeah. So Victor, you let the students choose their projects, or the teachers let the students choose their projects.
Yeah. And I would offer to be punchy back to you, being the third hour. Is we need to think about what we mean by efficiency and what does it look like when we attain that. So, is it going to be a better thing, societal efficiency, if we can have students identify the questions and challenges that are happening in their neighborhoods or in their lives and articulate those solutions? Or is it more efficient to have everybody learn a particular algorithm that is tried and true? Or is it more efficient to have teachers, focus their energy on making those decisions, and some of the more rote things like repetitive grading activities get offloaded to those? So, I think it's going to really depend a lot on what we mean by efficiency. What is that going to look like, and for who and what purposes? But I think if we keep everybody really reflective about why we're using all this data, then there's a chance to adjust to any of those aims.
But do you get pushback, say on your research from parents, or say things like, well, that's not the way I learned it?
In general, no, because I think that with data and statistics, there's this ongoing discomfort where everyone's like, oh, I would have got it a lot better if I did it that way too. So there's a lot of empathy with that. I think where we get a lot of pushback are these questions of privacy and just sort of how data is going to be in our lives. I've written recently on this, especially with education. Children's data is a sensitive, rightfully so, topic. And there's some specific issues and policies that we're going to need to examine to best set those.
Right. So, go ahead, Emma. Sorry.
I was just going to jump in and say that I think, again, I guess I tend to think of this in terms of if we're explicit about the objectives we want for education, then a lot of these choices will become part of, like, sort of in service to that. So for example, if it turns out that it is much more effective in terms of retention or long-term outcomes for students to like do their own sort of open project-based learning and like, define their own things, then we should do that. I mean, I'm fairly pragmatic about sort of like which of these things. I'm not particularly wedded to either or to any particular way of doing instructional design. I'm very excited to look at sort of what are the long-term outcomes and how do they align with what we want. And so if it turns out that sort of having localized autonomy by students is much more effective, maybe not for immediate test scores, but for long-term retention, then we should do that. But I think that it's really exciting to think about how we can sort of tie those to the outcomes that we care about. And then I think it also can avoid some of the, to be punchy, like it can avoid some of the sort of theoretical discussions that we maybe can answer with some forms of data now in terms of which ones are more effective and under what conditions and what do we mean by effective.
Right. So have people started doing those studies where they say compare AI tutor versus traditional classroom, and then they come back and look at the kids 6 years later? And
there's been a few, I mean, I think like people like Ryan Baker have done studies of looking at, say, tutor usage in middle school and then looking at things like high school graduation and I think STEM choice in college. So I feel like there have been starting to be some longitudinal ones, but they're fairly rare. I find those sort of things fascinating, particularly like some of the recent results that were reported about the studies in Boston of like the incredible effects of preschool in terms of long-term outcomes, 10, 15 years later. And so I think the more we can have some of that longitudinal data, that'll just be incredibly exciting and informing future educational policy.
What I'd say to that is just reminiscent of this ongoing perpetual debate between what has often been called like direct instruction versus open inquiry. And, there's actually, aside from all the caricatures that are being painted of one another, a pretty darn good convergence on, we should help students get to efficient ways of figuring things out. And if we know that, we shouldn't, keep it an eternal mystery. But at the same time, just dumping that information at them, and Dan, some of your own work is not the solution. There's times and methods for which that works. And a lot of it involves getting them to sort of think hard and wonder about it first. So it's a little bit of both.
Right. So, Victor, what is the dream data set you would like students to produce such that Emma could use it? Right. And so we can stay in the techno-athletics realm. Maybe
we could be off of it. I think that right now there's so much data that let's pretend it's high school and kids have their smartphones, all different models and such. It's really locked up in terms of getting all the data that is being produced with those. And I think if we could pull all of that, see how much of it is these kinds of things we might consider learning valuable and things that are within, an educational activity versus social media, and whether those actually really overlap. And you talked about some work by Byron Reeves and looking at rapid switching. I think if we could produce that, if we could give students access to that, because they know what they're doing on their phones, we don't as parents necessarily. And Emma and I could sit down and talk and say like, all right, we're catching it in the wild. We're getting all of this data. It's going to have holes in it. So we're going to need to do some interesting imputations and simulations to fill those holes. But I think we'd get a better shot of kind of like real life learning for these youth. So that's my dream.
What do you think, Emma? What kind of data? So Victor's in the business of having kids generate data. What would you like?
I think I would always love when there's some amount of randomization. And so like, I feel like in those things, if one could sort of cluster, encourage kids to try different types of things in the types of ways that they're interacting with the data, or cluster students and sort of nudge or suggest students try out different things, then that gives us some of the variation where we can then mine that data and try to look for sort of interesting patterns and insights over what might have happened if they had went down different paths.
Very good. Very good. So I still like the space of exercise for this. We could see what early behaviors lead to better health outcomes. Yeah. So time for one more question. And you two have gotten the big, vast questions that the other ones were sort of like, what's the name of that synapse in that region of the brain? You guys are getting the big questions, and you're doing so well. So here's the last one. What is your vision for public schools 2 decades from now? and if it helps, you can present an extreme and say, it shouldn't be that.
Can't we just answer with some names of neurotransmitters?
I can give a cop-out answer first, and then make Victor finish. So I guess my thought is, as again, I'm an artificial intelligence researcher, and I think it's been deeply exciting and deeply humbling to do work in the education space. And I think the more that I work in it, and these questions of sort of values and what are we trying to do, the more I think that like it absolutely should not be my decision in the way that school systems work. And it really has to be sort of a community-led effort to figure out, how, what are the important values of education, and then how do we make sure that our systems are aligned with that. And so it would have to be sort of a community effort around these types of ideals. I will say one thing that I would be really hopeful to see in the future, which is I would love to see better connections. I think of this particularly in my own space in higher education, but between education and the workforce, because I think we're going to need a lot more continual lifelong learning in the future because of things like automation and the job force training. So I'd love to see more ways for people to easily integrate learning throughout their life, beyond the type of structures that we already have right now.
Great answer. Great poll. That was really good. Victor?
Yeah, and I'll try to play the game with this. I mean, I think more equitable resource access, stronger technology integration, more empowerment for the teachers and the students to call the shots, drawing on the wisdom that they've got. But I also think what I'd add in there is more porousness with respect to grade levels and the community, so that you could sort of have the ninth graders mingling with the fifth graders, and they're sort of teaching one another, and the fifth graders showing the ninth graders something really cool and interesting. And you have, a data scientist from the community coming in, and the nurse coming in from the community, and they're all just exchanging wisdom and expertise, and that we have an infrastructure that's really quick to bring all that together and assemble, so that, something new can always happen. It'll be real interesting, hot, stimulating intellectual hotbed.
It's interesting. So so Larry Cuban, who was a famous historian in the School of Education, he really didn't think technology could change the basic grammar of schooling, right? Which is we have periods, we have age bands, we have classrooms, and you're both sort of proposing that maybe we're going to be able to change that grammar by making it more porous, less age banded, and so forth. So I'm impressed how well you both stepped up on that impossible question. So I want to thank you both, Emma and Victor, for bringing us home. It was a great session. And I want to thank all of you again for spending time with us today. I hope you learned a little more about how neuroscience, technology, and data are opening the door for new discoveries in learning and new applications and designs. The Transforming Learning Accelerator is Stanford's way of harnessing these discoveries to improve learning for all. And we look forward to being able to continue these conversations and creating more learning opportunities. So thank you, everyone.